Okay, in this video we're going to answer the following questions about function f of x being x to the fourth power over x squared minus 1. So the first question is whether the point 1, 1 is on the graph of y equals f of x. So to answer that question, we use the fact that the first quadrant is the value of x and the second quadrant is the value of y. So if we plug x equals 1 into the formula for f of x for an answer, we should get the y quadrant. Now if we calculate f of x, which is f of 1, we're looking on 1 to the fourth power over 1 squared minus 1. So this gives you 1 divided by 0, and that's an undefined value. So since there is no y value that corresponds to x equals 1, we draw the conclusion that the point 1, 1 is not on the graph of y equals f of x. Now for the second question, we have a question that if x is equal to 2, what is f of x? So this question is easier to answer. We just plug x equals 2 into the formula for f of x, into this formula for f of x. So if x is replaced by 2, we get 2 to the fourth power over 2 squared minus 1. That is 16 over 4 minus 1, and that gives you 16 thirds. The corresponding point on the graph will have x quadrant 2 and y quadrant 16 thirds. So the point with quadrants 2 and 16 thirds is on the graph of the function f of x. Now for the third question, it asks if the value of the function is equal to negative 112, what is the corresponding x value? So this is the reverse question. So this time this negative 112 is playing the role of y. So we know that the function is equal to, the value of the function is equal to negative 112. We have to recover x value. So instead of the function itself, we plug in, we write the formula that represents the function. So we put x to the fourth over x squared minus 1 instead of f of x, and all of this should be equal to negative 112. Now if we cross multiply, so we multiply x to the fourth by 12 and x squared minus 1, the entire expression, by negative 1, we get this flat expression. 12 times x to the fourth is equal to negative 1 multiplied by x squared minus 1. So if we distribute negative 1 over, we get 12x to the fourth is equal to negative x squared plus 1. Move all the terms to the left-hand side, and we're looking on this equation, 12x to the fourth plus x squared minus 1. So if we set u equals x squared, this equation becomes 12u squared plus u minus 1. So we get this quadratic equation in u, 12u squared plus u minus 1. So we're going to use quadratic formula on it to solve it. And when we write out the quadratic formula, we get this expression. So in the end, that is negative 1 plus or minus 7 over 24. And then we're going to find the individual u values. So the first u value is negative 1 plus 7 over 24. That is 6 over 24. That gives us positive 1/4. And the other u value is negative 1 minus 7 over 24. That is negative 8 over 24. That gives us negative 1/3. So continuing on, if u is equal to 1/4, we have that x squared is equal to 1/4. So x is equal to positive or negative 1/2. And if u is equal to negative 1/3, then x squared is equal to negative 1/3. And there are no real solutions in that case. So if f of x is equal to negative 112, then there are 2 points that correspond to that y coordinate. So the points on the graph are positive 1/2 and negative 112. And another point is negative 1/2 and negative 112. To find the domain of f, we see that the expression for the function does not contain any even roots, but it has a denominator. The denominator is x squared minus 1. So if we solve denominator being equal 0, we get x is equal to positive or negative 1. So we're going to exclude the positive 1 and negative 1 from the domain. And those are the only values that will be excluded. So the three intervals will constitute the domain of the function. So domain is interval from negative infinity to negative 1, together with interval from negative 1 to 1, together with interval from 1 to infinity, and all of the intervals are open intervals with parentheses. Now to find the y-intercepts, so we're going to set x equals 0 in equation y equals f of x. So we're getting y is equal to f of 0, so that's 0 over 0 minus 1. So that evaluates to 0. So y-intercept will be at 0, 0. Now to find x-intercepts, we set y equals 0 in the equation y equals f of x. So we get 0 is equal to f of x, which is the same as x to the 4th over x squared minus 1. So we solve an equation x to the 4th over x squared minus 1 equals 0. So that means the numerator has to be 0, so x to the 4th is 0. That gives you the only solution, x equals 0. So the x-intercept for the graph of the function is again at 0, 0. So we're going to answer the following 6 questions about the function negative 3x squared plus x. So this question asks if the point 1, negative 2 is on the graph of y equals f of x. So here we have that the x value is equal to 1 and the y value is equal to negative 2. So the easiest way is to plug in x equals 1 into y equals f of x equation and see if we get y equals negative 2. So f of 1 is equal to negative 3 times 1 squared plus 1. So just using the formula for the function. So this is negative 3 plus 1, which is negative 2, which is exactly the coordinates that we were given. So yes, the point 1, negative 2 is on the graph of y equals f of x. Now, if we're given that x is equal to 2 and we would like to know what f of x is, we just take the formula for the function and plug in x equals 2. So f of 2 is negative 3 times 2 squared plus 2. So that gives us negative 3 times 4 plus 2. That's negative 12 plus 2. That's negative 10. So the value of the function is negative 10. And the point on the graph is 2, negative 10. In the third part, the question is if the value of the function f of x is equal to negative 70, what is the value of x? So this negative 70 plays the role of y. So we have y equals f of x equals negative 70. So instead of f of x, we have the full right to put negative 3x squared plus x. So if we do that, we have equation negative 3x squared plus x equals negative 70. So if we add 70 to both sides, we're looking on the quadratic equation, negative 3x squared plus x plus 70 equals 0. So if we multiply through by the negative, we get 3x squared minus x minus 70 equals 0. And if we use quadratic formula, we're gonna look on expression like this, which simplifies to 1 plus or minus the root of 841 over 6. Which is the same as 1 plus or minus 29 over 6. So for the first x value, we have 1 plus 29 over 6. That's 30 over 6. That's positive 5. And another x value is 1 minus 29 over 6. That's negative 28 over 6. Reduce it by 2, and we get negative 14 over 3. So we have 2 points that correspond to the y value, negative 70. So it's positive 5, negative 70, and negative 14 thirds, negative 70. Now on to the fourth question. So for the domain of this function, so we look for any denominators in this function. And in the expression for f of x, there are absolutely no denominators. So we don't have any. any even degree roots, there are absolutely no roots in this function, so none of the two restrictions are present, so we have no restrictions on the domain of this function, so domain will be all real numbers. So domain will be the interval from negative infinity to positive infinity. So if we look for y-intercepts of the graph of the function, so we're going to set x equals 0 in this y equals f of x equation. So y equals f of 0 is equal to negative 3 times 0 plus 0. That gives us 0. So y-intercept has y value 0, and the point on the graph is 0, 0. And for the last question, we have the question to find x-intercepts. So we're going to set y equals 0 in the equation y equals f of x. So we have 0 is equal to negative 3x squared plus x. So you set the entire expression for the function equals 0. And if you solve it, you're looking on equation negative 3x squared plus x equals 0. So if you factor out x, you have x times negative 3x plus 1 being equal to 0. So this splits into two parts. Either x is 0 or this entire parenthesis is 0. So we have either x is 0 or negative 3x plus 1 is equal to 0. So solving the second expression, we end up with x being positive 1/3. Now there are two x-intercepts. So there is one x-intercept at 0, 0 and another x-intercept at 1/3, 0.